Welcome back to Mr. Hassan's Maths channel, and in this video I'm going to be going through question number 8 from the Solomon A, the C3 collection, which now has been changed its name to P3, Pure Mathematics P3. This is from the Edexcel International A level, and this corresponds to question number 6 from my end of topic worksheet 1, which is about algebraic fractions. And in this question we are asked to use algebraic division. We have to show that f of x equals, you have to show that f of x equals x to the power 4 plus x cubed minus 5x squared minus 9 all over x squared plus x minus 6 will become x squared plus a plus b over x plus c. So this becomes something in this form, and we have to find what those values of a, b, and c are once we've done that. So now, first of all, algebraic division is kind of similar to normal division. For example, if I do 17 divided by 4 and I want to set it up as like a long division, I'll put 4 on the outside of the division and 17 on the inside. Then I'll divide 4 by 17, and the number of times that 4 goes into 17 goes over here, and then the remainder ends up down here. Okay, so the same kind of thing. So this would be like 4 into 17 goes 4 times, and you'll end up with remainder 1. So you have 4 and 4 over, and 1 over 4. Okay, 4 and 1 over 4. Let me think of another example because we don't get the same number. Let's think of another example. Let's think of, say, 26 over, say, let's say 4. Okay, again. So 4 into 26. If we set up as a division, we'll have 4 going into 26. Now 4 goes into 26 6 times. 6 times 4 is 24. Subtract them, you're going to get 2, so you'll end up with 6 and 2 over 4, which ends up being 6.5 because you can factorize and simplify. So basically the whole number of times that the denominator goes into the numerator ends up over there, and the remainder ends up down here. So in algebraic long division, it's basically the same procedure as that, okay? But you're just dealing with algebraic terms. Okay, so now what we're going to do is we're going to write the denominator on the outside just like we did there. So x squared plus x minus 6. And on the inside we're going to put the numerator. So you have x to the power 4 plus x to the power 3 minus 5x squared. Now you've got to be very careful. I haven't finished yet, but you've got to be careful. In the denominator there's nothing missing in terms of the powers. You've got the highest to the lowest, x squared, x constant. Everything's there. But in the numerator, you got x to the power 4, x cubed, x squared, and then you got a constant. There's an x term missing. So you must always put a 0x or 0 whatever's missing. If it was x cubed that was missing, you'd put 0x cubed. Okay? From the beginning to the end, if there's anything that's not there, you have to put 0 of that thing there. And then you have your minus 9. The reason being, it keeps everything in the right kind of power position. Okay, it's like you could say place value. And when we talk about numbers here, we're talking about in terms of the right kind of exponent. X to the power 4, x to the power 3 is x squared, x is numbers. Everything has to be in line. Okay, now we're going to now do this division. Let me just make that look a bit neater. In fact, I'm just going to do this. I'll do this to make it look a lot neater. Okay, that's better. Okay, now, so what I'm going to do now is x squared into x to the power 4. So how many times does x squared go into x to the power 4? Well, it goes in x squared times. Because x squared times x squared is x to the power 4. Now we have to multiply x squared by all of these 3 terms and put the answer over here. So x to the power 4 and x cubed and minus 6x squared. And just like we do in long division, we subtract these 2 lines. Okay, now this will become 0. This first one should always become 0 because that's how you end up with this. You're saying how many times that go into that. So that should be the same number as that when you finish. But these don't have to be the same, but they actually happen to be the same here. So you end up with a 0x cubed, and you got minus 5x squared minus 6x squared, which is minus 5x squared plus 6x squared. So be careful about this minus outside. I always write it there to make sure we don't make a mistake. So that's minus 5 plus 6, that's 1, so that's 1x squared. Okay, and then I'm going to bring down not just one of the other terms, I'm going to bring down both of the other terms. Because there's altogether 3 terms here, there should be 3 terms here as well. Then I say x squared goes into x squared 1 time. So we're going to put plus 1. 1 into x squared, 1 times x squared is x squared, 1 times x is x, and 1 times minus 6 is minus 6. Now we're going to subtract these two lines. Okay, these ones will cancel. We have 0 minus x, you get minus x, and minus 9 minus minus 6, which is minus 9 plus 6, which is minus 3. Okay, so we have basically the whole number part, which is x squared plus 1, plus the remainder, which is minus x minus 3, over the original denominator, which is x squared plus x minus 6. Now, if we compare that to what we're supposed to prove, they don't look quite the same. Okay, in fact, they look quite a lot different. And that's not because we've done something wrong. Okay, that's because we have to do something else. Okay, we have to do something else. So this is what it actually looks like. Okay, I just lost it 1 second. This is what it actually looks like. I'm just going to copy this. Okay, what do I do? Go to copy. No. Maybe it's here. Yeah, copy this. Sorry about that. So this was the answer that we got. I'm just gonna paste it over here. Okay, that's exactly what we got. And if I paste it over here, okay, we can see that we have to make this become that. We have to make this become that. See, x squared, we got x squared plus 1 plus minus x minus 3 over x squared plus x minus 6. So how are we going to make this become that? Well, first thing I can see is this denominator can be factorized. So I have x squared plus 1 plus, and I've got here on the top, it's minus x minus 3. Okay, and this can be factorized. If you factorize this, you're going to get x term here and here, different signs because the product is negative. They multiply to give you minus 6, they add to give you 1, so it's 3 and minus 2. All right, now, they don't look the same, but however, what we can do here is we can say you got x squared plus 1 plus, now, if I take out a minus from these two terms, I'll put minus here, this would be x plus 3 inside the bracket. That's minus x and minus 3. And I've got x plus 3 times x minus 2. They'll cancel out, and I'm left with x squared plus 1 plus, and I got minus 1 over x minus 2. Now that looks the same as that form. You got x squared plus 1, so that means a is equal to 1. And you got plus, there's a plus here, then you got minus 1, that means b must be negative 1. And you got x plus c, so c must be negative 2. So there we have the answer to part A. Now part B and part C are about topics which are outside of this particular topic of algebraic fractions. They're things that come later on in P3. So I'm going to answer part B and part C as we come to them in other videos, in another video. I won't do it as one big video. So this part of the video will be for this algebraic division, and the other parts of the question I will put them in the playlist for those other topics, and we'll come to them as I get to them. If students ask, I'll answer those questions. So thank you for watching. If you would like to watch other questions from this paper, when I eventually get around to doing them, I'll put the playlist over here. Okay. If you would like to watch questions about algebraic fractions in P3, you can click on this playlist over here. If you'd like to subscribe to the channel, click on the icon over here, and on the top here I'll put something related to P3, which you can go like a playlist of something, maybe a past paper or something. I haven't decided yet. Okay, so something related to P3 should be up there. So thank you for watching, and I'll see you again soon.